right, hey guys. Today we're going to move on to section 5.1 in chapter 5. We're going to start off with perpendicular and angle bisectors and a couple theorems that have to do with them. So the first one is the perpendicular bisector theorem. And it says if a point is on the perpendicular bisector, so it's important for this that we have to remember what a perpendicular bisector is. If you look over here, line L is perpendicular, there's your right angle, perpendicular. And notice this is cut into two equal pieces. There's your bisect. So line L is a perpendicular bisector of segment FG. So it says if you have a point on this perpendicular bisector, it could be anywhere, so they put it right here, then it is equidistant, or the same distance, equal distance, from the endpoints of the segment. So what does that mean? From A to F should be the same as from A to G. These should be equal. And that's what the perpendicular bisector theorem is saying. If you have a perpendicular bisector, any point on that bisector should be equal distance to each endpoint. There's also the converse. If you see that it's equal distance, then you can tell me this is a perpendicular bisector. So there's the theorem and its converse. And there's a little example here which you can go back to and go over if you want, but we're going to go over a couple just like it. So consider that an extra bonus one. So we're down here. So we notice that this is perpendicular and a bisector because of those tick marks. So we know that any point on this perpendicular bisector should be equal distance from R to T as it is from R to S. So if RS is 16, then RT is 16. So we look at the next one. Next one's actually the converse. So notice here, here's your point. See how it's equidistant to both endpoints? Equidistant to both endpoints? Then you know that this is a perpendicular bisector. So this one's also going to be 2.5. But what do they ask for? They ask for from A to B. So you have 2.5 and 2.5 makes 5. And the last one is that perpendicular bisector theorem again. The reason I know I'm using it is it's perpendicular, right, line HL, and it's a bisector. So you know that any point on this perpendicular bisector should be equal distance from H to J as it is from H to K. So we know these distances are equal. We're going to set them equal. Let's subtract 3x from both sides and add 3 to both sides. And then divide both sides by 2 and we get, oops, x equals 2. I switched it around, but same concept. Now that's not what they asked for. They asked for hj. So we've got to plug it in. 3 times 2 is 6 plus 1 is 7, which should be the same as hk. So that's using the perpendicular bisector theorem and its converse. So remember this was looks like 1 and 3 were both the perpendicular bisector theorem. And number 2 was using the converse. So just if you want to see how they're different and how they work. Now when you move on to 4 and 5, it says write an equation in point-slope form for the perpendicular bisector of a segment with the given endpoints. So what on earth do I do here? I know I have 2 endpoints, which you can graph them if you want, A and B. And I want the equation of a line that's going to be perpendicular and bisect. So perpendicular, remember we talk about slope. The slope should be the inverse reciprocal. So let's find the slope of AB. Remember, it's rise over runs, so subtract your y's, 5 minus -3. And keep that same order, 5 minus -3, 0 minus 6. So here we have 8 over -6, which simplifies down to -4 thirds. And they're both divisible by 2. Now be careful. We want the perpendicular slope. So the perpendicular slope, negative becomes positive, and 4 thirds, flip it, becomes 3/4. There's my slope. Now how do we deal with the bisector? Well, remember for point slope form, you need a point and a slope. We don't want to use these points because those aren't on my perpendicular bisector line. We need a point that's bisecting. We need a midpoint. So let's find our midpoint of AB. So remember, midpoint is add your x's, so 6 plus 0, cut it in half, and add your y's, -3 plus 5, cut it in half. So 6 cut it in half is 3, and 5 minus 3 is 2, divided by 2 is 1. So there's my slope, there's my point, and I'm going to go ahead and we're just not going to do problem 5. And I'm going to put the answer over here. So we're going to put our final answer over here. So we want to use point slope form. So remember, point slope is y minus y1 equals mx minus x1. So it's y minus your y coordinate, which was 1. Slope, we said, was 3/4. And then x minus my x coordinate, which was 3. So this line right here, this is the equation of a line in point slope form. That will be the perpendicular bisector of AB. Perpendicular, we got that slope. And bisector, we got that midpoint to make sure that it's going through the midpoint and it's bisecting. If you want another example, they did one for you up here as well. So you do have a second example if you want it. All right, last piece. So that was all perpendicular bisectors. And now we're going to talk about angle bisectors, and it's kind of the same deal. If you have an angle bisector, so in this case, MP is an angle bisector, because it's cutting this angle into 2 equal pieces. Any point on that angle bisector should be equidistant to each side. So from P to L should be the same as P to N, equidistant to each side. And again, the converse is just thinking about it backwards. If it's equidistant to each side, then yes, MP is the angle bisector, and you can tell me those are 2 equal angles. So there's a lot of equal stuff going on, a lot of congruency. So let's look. So here, I see that FH is an angle bisector because they're marked those 2 congruent angles. So any point on this angle bisector should be equidistant, that's 23, to each side. This will be 23. That's what they wanted, EH. All right, next one. So here they don't tell me it's an angle bisector. This is that converse theorem. If you have a point that's equidistant to each ray, then you know that it's on the angle bisector. So you know that this will be 26 degrees as well. Now be careful, they asked you for angle QRS. So they want that whole thing 2 times 26. And you get 52 degrees. So they wanted all of this, QRS. So make sure you pay attention to what they're asking for. And then the last piece, again, this is that converse theorem. It's equidistant. right? Z is equidistant to each ray, so you know this is an angle bisector. So you know this angle has to equal this angle. 2x plus 5 has to equal 4x minus 25. Let's subtract 2x from both sides. We'll add 25 to both sides and divide both sides by 2. Now again, make sure you give what it asks for, WXZ. WXZ is just this one little angle, so we have 2 times 15, which is 30, plus 5 gets me 35. And had they asked for WXY, you would have had 35 and 35, you would have said 70. All right, next one. So we're going to actually mark some stuff in this picture. Given that JL, these are all individual problems, but same picture. JL bisects angle HJK, so we know this is bisected. And LK is 11.4. Find LH. Well, if it's an angle bisector, that's 11.4. That's 11.4. That one wasn't bad. Now I'm going to erase. You're going to do the same thing in your work today. And then you're going to treat this as a new problem. So LH is 26. LK is 26. HJK is 122. Find the measure of LJK. So they just want one of these. Well, you know if it's equidistant, then you know this is an angle bisector. So if they tell you it's 122, half goes in each, so you get 61 degrees. So this one would be 61, and this one would be 61. Because you know this is an angle bisector. Alright, last one. Hopefully it all comes off. Alright, next one says LH equals LK. LH equals LK. The measure of HJL is 3y plus 19. And LJK is, I'm going to put a little arrow, 4y plus 5. Oof. Handwriting's bad right now. Oops. 4y plus 5. Find the value of y. So again, you know if it's equidistant, then you know this is an angle bisector. Right? JL is an angle bisector. So these two angles are equal. Set them equal. 3y plus 19 has to equal 4y plus 5. We're going to subtract 3y from both sides. And we're going to subtract 5 from both sides. And that's what they asked for, y equals 14. All right, that's it. Go do your homework. I definitely want to see the work shown. So even if you just divided by 2 or multiplied by 2, like we did here, I want to see that shown. Now, if it's just equal, obviously there's not much work to show there. But if you did any type of math, I want to see the dividing by 2 or the multiplying, or definitely the algebra. Get your homework done, upload it to Focus. Bye, guys.